Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 11D assignment. Okay, so first one, number one, the tangents at points A, O, and B are horizontal. Classify points A, O, and B. Okay, so we'll do that first. So A here is definitely a maximum, right? But if you'll notice, this graph here has got an arrow, so this is going to go forever and ever. So it's only a local maximum. And then let's see O here. That's right here. It doesn't actually have the letter O unless you consider that circle there. But so this O here is that stationary inflection because it's not a maximum or a minimum. So it's a stationary inflection. Okay, and then B is a minimum. But again, this arrow here goes forever and ever, so it's just a local minimum, not a global minimum. Okay. Part B, draw a sign diagram for the gradient function f prime of x for all x. So really we can just do this here. So here's B. So at all of our turning points here, so we've got one at -2, we've got one at 0, and we've got one at 3. So this thing here is increasing here, so that's positive. This is decreasing to 0, so that's negative. And then actually from 0 to 3, it's still decreasing, so that's still negative. And then from 3 on, it's going back up, so that will then be positive. So then part C is state the intervals where f of x is increasing and decreasing. So increasing does not have a beginning, but it does end at -2. So let's do this beginning, or we did start and stop, didn't we? Let's do that. Let's stay consistent. Start and stop. So increasing, it does not have a beginning, but it does have an end. It stops when x is -2. So it's increasing when x is less than -2. And then it's decreasing. Well, the beginning of the decreasing is from -2 to 0. And so it is decreasing there. And then the next one's also decreasing. So that begins at 0, and then it ends at 3. And then the last one is back to increasing. Where does that start increasing? It starts increasing at 3. Where does it stop increasing? It doesn't. It goes on forever and ever. So that's simply when x is greater than 3. So we are increasing when x is less than -2. So here's -2, and it's less than anything over here. As we're reading it left to right, it's going to be going up. And then it's also going to be going up when x is greater than 3. So here's 3. Anything more than 3, it's going up. And then it's decreasing between -2 and 0, and then also between 0 and 3. Okay? Really, we can kind of combine these two here since it's always decreasing there. So these two here could just turn into starts decreasing at -2, stops decreasing at 3. So we could just do that instead. That would be a nicer way to write that. Okay. Draw a sign diagram for f of x for all of x. Really small thing here, which makes a big difference. We're drawing a sign diagram for the gradient function f prime of x for all x. This is, so here's our derivative. We're looking at the derivative function here. Okay. What this is asking us for, draw a sign diagram for f of x for all of x. So now, pretty much, let's do this part in red to make this a little easier. So all of this here, the y value is negative, and all of this down here, everything below the x-axis, everything's negative. Everything above the x-axis is positive. So our sign diagram for f of x is going to look a little different. Okay, so where it's negative here is, this point here is -4. So it's basically all the spot, we want to write down all the spots where it crosses through the x-axis. Okay, so -4, 0, and 5. Okay, so if it's less than -4, all of these are negative. When it's between -4 and 0, those are positive. When it's between 0 and 5, those are back to negative. And when it's greater than 5, those are back to positive. So this is f of x, and these are all of our x's. So then the f of x is essentially the y. So again, if y, the x value is between -4 and 0, right in here, our y values are going to be positive. That's what that's saying. Okay. Number 6, for each of the following functions, find and classify any stationary points. Sketch the function showing all important features. So let's do the smarter, not harder version of this. We've got x squared minus 2, and we're going to graph that thing. Okay. Find and classify all stationary points. Sketch the function showing all important features. Okay. So our graph looks like this. It is crossing through at -2. There's our y-intercept. Right? Sorry for the curvy lines. You guys get the idea. And then we're going to want to find what these two x-intercepts are going to be. So let's do this. Second trace, which is calculate, and we want to find those zeros. Okay, so left bound. Got to get that cursor there to the left before it's crossed through the x-axis. Okay, now it's to the left. And then we got to move it over to the right after it's crossed through the x-axis, which is there. That works. And then enter. And what it's going to do, it's going to find the sign change between those 2 points, which is -1.41. So we graph this thing. We get that this is at 0, 2. That point right there is at -1.41 and 0, which actually 1.41 is the square root of 2. Okay. To find this one here, that's going to be the same as, but the positive version of that. But we can still go through and show how to do that. I'm going to go through and do the 0. So I'll move this over here. That's actually fine as long as it's to the left before it crosses through, and it hasn't crossed through again. And now we got to move it to the right until after it crosses through the x-axis. So there, it's definitely crossed through. Oops, it keeps going. Enter, and then there's our 1.41. So then this point here is at 0 and 1.41. Oops, sorry, 1.41 and 0. Okay, so we've and classify the stationary points. This here is a global minimum, right? Because that graph never ever gets lower than this point here. Okay, that's all we got to do for that one. So we'll do the same thing for G. Put that into the our y equals and graph that thing. Okay, so we get this crazy looking graph. Goes up here, and let's see, we know that we can't put 0 in there, so this is actually an asymptote right here. So it's not going to come up here and hook back together there. They're going to be 0 is an asymptote there. So this is a crazy one. So I'm going to give this thing here a sketch. And just label all of our important pieces. So our x-intercepts are our important pieces. So that's going to be at something and 0. So we can calculate what that is off of our graph. Second trace, we want to find that 0. So that's number 2. And let's see. Left bound negative. There we go. Now we can see it. Got to get it before it crosses through. So that's before. And then we move it over after it crosses through the x-axis. That's good enough. And then it will tell us what our x-intercept is. -0.793. -0. Here, let me try this again. Just to give myself enough room. Negative 0.793, and 0 is this x-intercept. There is no y-intercept, so really the only other important feature there is going to be this local minimum. It's the lowest only in this area because obviously it gets smaller over here. So to find what that is, we can do second trace, which is calculate, and we want to find that minimum, which is number 3. Okay, move this over. I'm going to have to do it kind of slow because if we go too fast, it's going to get too far down there. So there we go. It's to the left of the minimum. Push enter. Move it over so it's to the right of the minimum. That's to the right of the minimum. Push enter again a couple times. And it will tell us that the minimum is 0.99999. That means it's 1 and 3 right there. So 1, 3 is our local minimum. Okay? Moving on here. Number 9, f of x equals x cubed plus ax plus b has a stationary point at negative 2, 3. So that means it's a maximum, minimum, or a stationary inflection, right? So find the values of a and b, and then find f of x, and then find the position and nature of all stationary points. Okay, so let's just one piece at a time. Let's figure out what, if we can, we'll figure out what a and b are. Okay, so it's got a stationary point at negative 2, 3. So that means the derivative, like if it's got a stationary point, like say this, let's pretend that that's it, that stationary point. That means the tangent, the slope of the tangent is going to equal 0. So what we're going to want to do here first here, for a, is take f of x, x cubed plus a, x plus b, and we're going to want to find the derivative of this thing. So 3 times 1 is 3x, subtract 1, and that's x squared. This is 1. 1 times a is a, subtract that 1, and the x's are gone, right? And then b is just a constant. So actually the b is gone too when we take the derivative, right? Since we know that this thing here has to be, we're trying to figure out, we know that at the stationary point at negative 2, 3, we know that this thing here has to equal 0. Okay, so really all we have to do is plug the negative 2 in for the x here. So 3 times negative 2 squared plus a has to equal 0 because it says it's a stationary point. So we know that the tangent, the slope of the tangent, has to equal 0, right? So there we go. Now we can just simply solve this thing here, and we can figure out what a is. Negative 2 squared is 4, so that is 0 equals 12 plus a, so subtract 12 from both sides. A has to equal negative 12, okay? So now that we know that a is equal to negative 12, now we should be able to figure out what b is, right? So then continuing on right here, if we go back to our original function, f of x equals, if we plug in our x's and our a, we should be able to figure out what b is, right? Let's see. Excuse me. What we really want to do is, look, we have an x and a y value. So let's plug in, this is our x and this is our y, right? F of x is what y is, so we'll do this instead. 3 equals, and then we can plug the x in, negative 2 cubed plus a we now know is negative 12 times x, which is negative 2, plus b. Okay, so now we should be able to figure out what b is. Negative 2 times negative 2 is 4, times another negative 2 is negative 8. Negative 12 times negative 2 is plus 24, plus b, right? So 3 equals 16 plus b, subtract 16 from both sides, and we get b is negative 13. So b is negative 13, a is negative 12. Okay, so that's part A. Find f prime of x, so the derivative of our x function. And we're going to want to plug in our a's and our b's in here so we can take our derivative. So f of x, we now know equals x cubed plus, actually it's plus negative 12, so let's do this. Let's put minus 12x minus 13, right? So we plugged in, because this is our a and this is our b, and so now we can take the derivative. 3 times 1 is 3. X, 3 minus 1 is 2, right? 1 times negative 12 is negative 12. Subtract the 1 there, and our x's are gone, and our 13 is gone. So there's our derivative function for b. And then part C says, hence find the position and nature of all stationary points. Okay, so basically we would we know that all stationary points, the slope of the tangent is 0, right? So 0 equals 3x squared minus 12. Let's divide everything by 3 to make our life a little bit easier. 0 equals x squared minus 4. So really we want to try to factor this thing out, right? And that's a difference of two perfect squares, right? So x here goes here and here. Square root of x squared is x. The square root of 4 is 2. One's positive and one's negative. Just to show you that this works, x times x is our x squared. X times negative 2 is negative 2x. 2 times x is positive 2x, which cancel out, turn into 0. And then 2 times negative 2 is negative 4. So we got our negative 4 and our x squared, and those two pieces dropped out. Okay? So that means the x coordinates of the stationary points are going to be at negative 2 and positive 2. Okay? So to find the y coordinates, we got to plug those into the original function, which is this one here. Here's our original function, right? So if x equals negative 2 and then x equals positive 2, so we could do f of negative 2 equals negative 2 cubed minus 12 times negative 2 minus 13. And then for x equals 2, f of 2 equals, I'll move this over a little bit so we can see it better, 2 cubed minus 12 times 2 minus 13. And then we can just solve each of these. This is going to be negative 8 plus 24 minus 13. So f of negative 2, negative 2 equals, let's see, that's going to be 21, negative 21 plus 24, that's going to give us 3, right? Yeah. So that means one stationary point is at negative 2 and 3, and then another stationary point is going to be 8 minus 24 minus 13. So that's going to be negative 29. So the other stationary point's going to be at 2, negative 29. Okay. Oops. So find the position and nature of all stationary points. So if we're going to sketch this graph here really quick, this is positive x cubed. So that if it's positive, that means it's always going to end up going up. Okay, and then since it's x cubed, there's 3. You always subtract 1 from the power, the highest power, and that's how many turns it's going to have. So it's going to turn twice. So basically it means it's going to look something like this. Okay, so let's see, negative 2, we're just going to call this negative 2, 3. And we're going to call this, even though it's certainly not accurate comparatively, but we're just sketching our graph, that's going to be 2, negative 29. And so this is a local minimum, and this is a local maximum. Okay, so that's all this stuff right here. There's our other coordinate. Okay, one more. We're going to look at 11. Find the greatest and least value of this in this interval. Okay, so really probably our easiest way to do that is we can just plug this into the y equals, we can plug this into our graph here and find our minimum and maximum value, well, sorry, the greatest and least value on that scale there. So let's enter this thing in. So we've got x to the third minus 12x minus 2. Now, what we can do is I'm going to do this. On the window, I only want to see from -3 to 5. I don't want to go any more than that. So my x minimum, I'm going to put -3. And then for my maximum, I'm going to put just 5 in there. Okay, and then we can graph that thing. So there's our graph, goes up, comes down. Hopefully it's going to come back up here. Oh, yep, there it goes. Okay, now that thing's shooting way up there. So X-Y's we're fine, but we definitely want to see a little bit lower, and we're probably going to want to see a lot higher. So window, our Y minimum, I'm going to put to at least -20. And again, this is really pretty much guessing. Y maximum, I'm thinking I'm going to want to see at least 50. So let's see if we can see everything that we want to see at that point. Okay, so it's there. Ooh, yep, we've got the minimum, and then, ooh, we still can't even see that maximum there. But here's the good news. So we know the maximum is going to be over here, and then our minimum point is going to be here. So let's find that minimum point. So we do this second trace. We're going to find the minimum. Okay, and that's actually in a good spot. Enter. And then I got to move this over so that it's past that minimum point. I'm going to keep going just to make sure. There we go. It just takes a little while on my computer graphing calculator here. So push enter and then find the lowest point. It should be right in here somewhere. That's at 2, -18. So minimum is 2, -18. Okay, and then now the max we know is going to be up here right at the end of the scale at 5. Okay, so on the graphing calculator, what we can do is we can simply just plug in 5. Actually, here's the easy way to do it. Second trace, and then we want value. If I push enter and I push value and I push x equals 5 and push enter, it's going to tell us what the y value is. So the max is going to be at 563. Okay, and that's the nice way to do this, since you are able to use your graphing calculator. If you weren't able to use your graphing calculator, what you'd want to do is you want to find these turning points here, and then you'd also plug in -3 into the equation, and you'd plug 5 into the equation as well. And that would help you see if you had any minimums or maximums besides where your turning points were. Okay, and actually they show a really good example of that in our textbook. But since we can use the graphing calculator, this way is much quicker and I believe a lot easier. So all right, that's all we have for 11D. If you have any further questions, please feel free to ask. Thanks.